All right. Good morning, everybody, and welcome to episode 6 of MakerBot Chats. As you guys know, my name is Felipe. I'm a creative director at MakerBot, and right now I'm live from New York City. It's great to be joined by you guys as every Wednesday. This is the sixth time that we've done this so far. I think it's been pretty good. I'm happy about them. I'll just do a quick rundown of what we usually do here. It's basically an open space for you guys to ask questions. So if you guys are joining us in YouTube, do post questions in the comment section to the right, I think, to the right of the window. Also, since these are persistent, so you can watch them at some other later time, we do read the comments, and that helps us a lot in creating new content, deciding what is it that we're going to talk on next episodes. Today's episode is an interesting one. We were going to be talking about how do you get from concept to prototype. In this case, I have some very specific applications that I've been working with here at my place. Different materials, different print settings, and it's been an interesting time, because a lot of people are getting their hands on either desktop systems or printers that they can use at home. And because of that, there's a lot of questions popping up of, how do I orient my part? What are the implications of different settings or print settings that you might want to use? And ultimately just, general best practices on 3D printing, from materials to the settings to the systems, what are the better things about each of the systems. But, I'll just start with a problem as you usually do. Let me switch over here. A problem that I had at my apartment. So as you guys know, quarantine has been tricky for all of us. But one of the things that happened was that we needed a new hanger. Basically, my wife was trying to figure out a way to put something in the door, and it's hard just to get out and buy something. And since I had the method here, I was like, well, maybe I can just drop something in the method and then figure a way to hang stuff against the door. I'm sure that you have all seen similar systems or similar setups where you basically just have a little hook. And let me go back to my webcam here. So, a simple hook that you can put on the door. So this basically is the width of the door. And the hook will hold whatever it is that you want to hold, right? In her case, I think she wanted to put just like the towels after showering and then also some dryer or something. Anyways, but it was an interesting problem, right? Because it's the challenge here is that you're trying to create something fairly robust. This needs to withstand at least a good 5-10 pounds, so that's 2 to 5 kilos, depending on whether you have a wet towel or you have the dryer hanging in there, and you do get some structural help from the door itself, right? As these nests in the door, that door is going to prevent this frame from cracking or from bending. However, it's as you try to make it thinner and optimize for the better part, then it becomes a little bit trickier. As you add functions too, it becomes a little bit trickier. So I started with something very simple, very thin, that was just basically one of these disconnected to a different system, right? But you can see like the general idea was already here, right? I was trying to see, okay, how thin does it need to be? These radius become really important because, when you get started, it's really easy to forget that anything that doesn't have a radius, it's kind of just possible in the 3D world, right? In the CAD environment. If you don't give smaller radiuses for your parts, it's going to be really hard for you to achieve two things. If you're trying to render it out, just smaller radius will really make the part stand out and be more believable, because ultimately there's really no industrial process that can create like straight on, like ultimately flat parts. So, and 3D printing is no difference. In this case, it's not only for you to be able to print it better, but also to dissipate a little bit of the stresses that will be created in each of these corners as the part nests against the door, right? So I started with something very simple. It's basically just an extrusion, that same idea of the hook. This one was about 1/2 inch. It was like, yeah, I'm printing it in polycarbonate. That should be fine. But of course, I printed the first version and it didn't really play out. So I thickened it a little bit. So this is kind of like the first real working version. And the interesting thing here is that just by having the printer readily available, I was able to do this back and forth. And this was true here in my living room as it is back at the office, right? So I'm fortunate enough to have a printer at home because of the current situation. But back at the office, I also have a direct access to the printer for when when we're developing new products, new components of the new printers, and the implications of that are that I am able to just test out the ideas, right? I don't have to necessarily wait to have, the part delivered, the part shipped over, but I can just go ahead and do a quick test and say, hey, okay, let's see, does this work? Test it real quick, test for the form, the fed, maybe sometimes even the function. Is it strong enough, or what can I change, right? And this was kind of the first pass at it. It's a very simple structure. It's just an extrusion, minor radius is here, so no need for supports or anything like that. But it printed okay. However, I printed a few of these and some of them started failing right here in the neck, right? And you can imagine why. It's basically this thickness is given by the thickness of the door, the offset between the door and the door frame, right? That's the minimum thickness that I can, well, actually the maximum thickness that I can make this part so that it will still slide into the door and the door will close. And that's one of the things that we as designers, as engineers, always have to think about, right? What are my constraints? Which ones of them are set and which ones of them I can actually work with a little bit more. So in this case, the offset between the door and the door frame was set, right? This is a set constraint. The width of the door as well. However, this little guy here doesn't necessarily need to follow that same rule, right? Because I'm not longer prevented, if you can picture here the imaginary door here inside of the hook. This part no longer is prevented to be thicker as it gets out of that door frame, right? So all of this section was needlessly feeble because of the fact that I just assumed that I'll just continue the same profile, and I did change it here on the first go, right? I knew that this U section needed to be stronger because it's actually the hook. However, this part, you can see how it bends already, and it's going to push a lot against the door, so the door will give it some more structural rigidity and integrity, but it only gets you so far, right? You can see how as the stress builds up, tension will start appearing both in this corner and in this corner. In the lower corner, I don't really have a lot of issues because there's enough beef in the material to withstand that stress. In the top corner, however, right, you can see how fast that part will try to fail. And even though I'm using polycarbonate here as a material, so it's also white, but it's cool for the bathroom. But it's a strong material, but it has its limits as any material. So anyways, I started prototyping with it, saying how can I change this part? As I said, understanding what were my requirements and my constraints, and keeping that same door thickness constant, but allowing myself for a little bit more beef, a little bit more material here in the part, so that I was able to actually, strengthen the part and ultimately benefit from the structure that the door itself is giving me, right? So the door is already beefing up my part. I added this little detail that was just like for me, to remove a little bit of material, maybe some of the print time. It's also better, I would say, to have this section right here is going to add walls, and I'll talk about walls in a second, but it's going to add walls to my material, or complexity on the walls. That will also help with the beefiness of the part, specifically when talking about 3D printed objects, right? If this was injection molded, removing material would probably weaken it. Since this is going to be a 3D printed part, adding a little bit more surface area to those walls, instead of flowing flat through it, it's going to increase the amount of material that I have, the strongest materials that I have, because the infill, unless I'm using 100%, which I definitely could, but I didn't really want to do that because, it's just, and for this part, it ends up being a little bit of a waste of time and material. But adding a little bit of detail here will add a strength to my wall, surface area to my wall, and ultimately will create a beefier part. So second iteration, and here's where I go back to my prototypes. And again, having the printer right there, being able to not, rely on a service bureau on shipping it out, it's amazing. I mean, in the house, it's unbelievable. In the office, it's really, really important because it actually frees you to just use the resource, right? You don't think in the office about the amount of, well, you do, right? You don't want to print too much paper, but you don't think about, the amount of ink that you have in the pen, right? You're just using it for what it is. You're using it as a tool. So second iteration, you can see how much beefier it is. It has that little detail that I was showing. I'm hoping that you guys can see the light. Maybe it's helping me or not, right? But if I flex them both, so see how this flexes, right? Quite a bit. and this guy stays there and just stays fixed, right? These straight sections stays put because of that added material. It's going to be a little bit, delicate on that corner, but this is enough for me to guide those stresses into the wall, into the door itself, and out of that corner, out of that very thin piece, which is sort of a requirement. I could also make it a little bit thicker here because, again, as I said, the door is inside. I don't really have any material preventing me from going wider, but I wanted to keep it simple. And, second and final step was, oh, and by the way, if you have any questions right now as I'm going through these exercises, do post them in the comment section. Alejandra is running the show behind the scenes, so thanks a lot, Alejandra, for doing this for all of us. If you have questions, do post them out there, and I'll answer them as we go. But right, third iteration and final iteration was the ask, another ask from the user, my wife. Well, you know what? I want to hang multiple things from these hangers instead of just having one, because maybe I'll have one towel or two towels, or one towel and then my shower cap or something like that. So third and final iteration was just this, double hook element, taking some of the learnings that I had so far, from thickening the material out, making sure that I was following similar lines. I already knew like what was the thickness right here in the actual hook area that was going to work for me. What was the simplest way to print it? I already learned about the orientation, the limits even that I had when creating these radiuses. Since I'm going to be printing this part, I wanted to print it without supports, right? So there's a limit to how steep I can make this curve, this radius, before it starts requiring supports. And supports, I'm sure you guys are familiar with, but just to touch on that, with FDM printers, you need some sort of material for the upcoming layer always, right? If the layer that's next over, so you can imagine if I zoom in here real close, right? The bigger this radius gets, the more likely it is that I will have the need of having some sort of scaffolding here for that material to be presented from the printer, right? So that the next layer over has a place to start. If I make this too big, then I need supports. If I need supports, I'm going to affect the print time, and ultimately it just takes more material. It's kind of, it's a very simple exercise, but I wanted to make it work as well and simplify it too. Some of the things that I could have done, differently, I think, thinking about it right now. So third iteration, here's kind of the whole process, right? From very, very simple, user wants a hook, this sort of works. It has its, limitations on the weight, on the load. How do I improve on that? How do I make sure that, the weight is actually something that it can carry, that I can go a little bit above of the weight and not compromise the part, compromise the product. And third iteration right here, right? So final member of the family. Let me try to hold them better. So third iteration is going to be this final one, double hook, multiple features sort of a thing, still coming along from all of those learnings that happened throughout the process, right? That started stacking up and sort of iterated and improved on my understanding of what was the limitations, the requirements, even that conversation with the user, right, starts to become relevant, because it's not only what happens on my end, knowing what is the material, how is the system going to behave, what is the better application, what is the better orientation, but also hearing the user, right? The user now wants, oh, you know what? It wasn't just the one hook. I want multiple things because it's going to be there in the door. So I might, it's the bathroom. I want to host as many things as I can. So you learn in the process, and it's important to say that you learn so much by having the part, right? And that's, I think, one of the things that I like so much about 3D printing as a concept. The fact that it takes that idea that I may have already in Rhino, right? I may have SolidWorks, Fusion, whatever it is. I may have the idea of how it's going to behave. What am I trying to achieve? What am I trying to do? But it's not until I have the prototype in my hands that I'm able to really test out, oh, you know what? Is this enough? Is it not? Is it going to bend? Is it not? Does it require a little bit more material to it or not? And even simple things as, do I like it, right? Do I like how it looks? Is it going to work for the user? Is she actually happy with having this separation between the offset between the two hooks? Is that enough for her to actually hang multiple components, or not components, but multiple products, say the towel and whatnot, from this hook. And so far she's happy. So it was pretty good. I'll just check real quick on the questions. Okay, so how do I prototype faster? Well, I think that the fastest way to prototype is to prototype as much as possible, right? The more options you have, the more learning that the more sort of knowledge that you will acquire, the better you will understand not only the process and the material, but also the limitations and especially the problem at hand, right? What am I trying to solve? It's not just a hook, but it's a hook in the door that has a certain width, that has certain uses, applications, and whatnot. How do you determine whether hollowed or latticed interiors? Oh, that's a good one. How to determine whether hollowed or latticed interiors work best? So I'm assuming that you guys are talking about interiors as the infill structure. That's what we call infill in MakerBot. Let me switch over to our trustworthy MakerBot print. So here we are in MakerBot print. Let's do a new build plate for this. So dark clip, oh, you can see, even here, dark clip double reinforced. Let's bring the double here to MakerBot print. Oh, that's not the one, actually. This one. Okay. So the reinforced door clip. What you guys are seeing right now is MakerBot print. So it's the instance of MakerBot that will control the output in the printer. And basically, it's super straightforward, but there's a lot of questions that come as soon as you get into the software, right? First of all, you can import like however many file types you can imagine from SolidWorks, Fusion. There's even plugins that actually install directly in SolidWorks and Fusion that you can super easily use to export files directly into MakerBot print. But what this is going to do is, as you see, it's going to take my original Rhino file, my original geometry, and convert that geometry to instructions that the printer itself can follow. And going back to that question, right? What's the best type of lattice or infill, right? That's a word that we use at MakerBot. The best type of infill that you might use, it's a broad question because the answer is kind of, it depends, right? What are you trying to do? And I think I touched on it at the very beginning of the conversation, right? I could have done it completely solid. So you can actually click here, in the print modes. We have one that's solid mode. It basically means everything gets filled up. And I can demo it real quick. So the standard infill is going to be this sort of linear pattern that basically has lines crisscrossing across the part. In the case of this specific part, and also the standard amount of infill is 20%. So that's kind of the density, right? I had a friend asking me over the week, how do I change the density of the part? How do I make it a little bit beefier? The beefiness and the infill doesn't necessarily equate one-to-one to the infill density. As I was saying, right, this one is 20%, and you can see like this is the pattern that's being generated, right? This is like the how much material am I going to have inside of this part, and it creates this lattice pattern, this sort of crisscrossing path that we called interwoven, I think. And if I do the solid one, let's switch over to solid. Done. And by the way, all of this is free for you guys to use. So if you don't have a printer, a MakerBot printer, you can 100% just download it and check it out, see what are the options that you can play with and how does the software work. So I am now slicing for a solid part, right? I'm trying to create a part that's completely hollow-less. So it's full of material, right? It's trying to fill up all of the interior of the part with as many layers of materials as possible. So it's going to split that that part into as many layers as possible, and it's going to create, you can see the difference already here. It's creating something that's completely full of plastic, right? The plastic is covering the whole part, so all of the layers are completely solid. There's no spacing between the layers. It's just basically not only outlining, but filling up all of the outline of that part, right? This is not the only way to make a part really strong. You could also think of, I would say, there's too big. Let me change the print mode again. Go to balanced. Balance is kind of our default. It's the sort of not so hot, not so cold, standard, super easy to use. The one that we recommend. And I was going to say, like, there's two ways of changing the structure and the density of the part. It could be either through the infill, right? By choosing solid, the solid mode, basically that'll pump up the infill density to 100%. It'll take it through the roof, everything that you can do, cover it up. However, there's another way that doesn't necessarily use the infill, but rather uses the wall thickness. So the walls, and then you can go, so I'm going to custom settings. So by the way, some of the options that you see in MakerBot Print are just, the starting points. Not everything is exposed. There's a lot of other options that you can choose from in the custom settings menu. So if you have questions on that, also do let me know. But I'm talking about the walls themselves. So the shells, right? And I can say here, okay, how many shells do I want to have? Let's see. Where's the number of shells? Oh, it's already there. So number of shells, here we go. So the number of shells, I'll slice it both ways for you guys to see. The shells are the outermost layer of my part. That's actually the profile of my part, right? Literally the shell of the part that contains the infill inside. Our default, our standard is 2 shells. So that basically means 2 solid walls of material enclosing the infill. And you can already see it here, right? So I'll zoom in, so you guys can see it. These are my shells. These are the 2 shells that I'm using. This is the infill, that crisscrossing path. And well, on the other side, you have the other shell, the other end of the egg, let's say. If I change that, right? If I go here again, where are my shells? Here we go. You have like however many you want, 2, 3, 4, 5, 6. The shells take a little bit longer than the infill to print. So you have to keep in mind that. So for example, another good ballpark is like 5 shells. That will make this part, in many areas of the part, and I'll slice it again. So slicing, it means just doing the preview, seeing how it's actually going to print. With five shells, most of the part is actually going to be just covered because of the offset that, then there's only so many shells that you can make before they start colliding into one another, and it basically becomes a solid object, and you'll see it in a second. So here, right, we have, let's see, 1, 2, 3, 4, 5 shells, right? Exactly. I mean, expected. Sorry, I'm not trying to do a Sesame Street or anything. But anyways, you can see how much more beef it adds to the part. And the shells are different than the infill, than doing a solid print, because it does affect the print time. But I would say that if you're trying to create something stronger without necessarily having to do it completely solid, because that might not be the requirement, the shells are a better place to start before trying to make something entirely solid. I think that the shells will add way more strength than you would expect, than just elevating the infill. Why? Because the shells actually focus on the outermost part of the parts, and as I was saying, since that offset comes from the outermost part of your object, that means that many areas here are basically just going to be completely filled up, and those areas are the tiniest ones, right? The smallest ones. But it will still have, wherever possible, it will still have that 10-20% infill. So you get the benefit of both things, right? You get super strong elements, super solid elements where you need them to, right? Where the part is really tiny and thin. And you get the infill, the sparse infill, where it's like, it's not really that important, because as you can see here in the cross section, this area has enough material, right? It's going, if this breaks, probably the whole part, the part as a whole, has already failed way before this happened. So are supports always necessary when prototyping? That's a good question. And as I was saying, like, it's no. And in this case, actually, the visualization here shows the supports in yellow, or this orange one. So those are the supports. These are not needed right here. It just has that as a default because of the fact that it's looking for, here we go, the supports. It's asking me, okay, what's a support angle? Meaning, if a geometry goes beyond a 40 degree angle, in steepness, just generate supports so that it has the scaffolding to continue on and keep building on top of the previous layer. Now, you can disable the supports here easily. You just say support type, none. Again, do the print estimates. And this is going to do two things. First of all, well, won't create supports. And because of that, you will save a lot of time. Ideally, when you're just drafting the idea, when you're just testing something out, you don't really want to have a supports, or you want to have a part that's simple enough. It's not always possible, right? It's not always possible to do a part that will not require supports. And that, just to continue with the thought experiment or the experiment here, this is 3 hours 20 minutes. If I used supports, let's go back to I am just going to change going back to the supports. So 3 hours 20 minutes without supports, and let's see how much it is with supports. But it's basically going to add a lot of time and of course a lot of material as well, the support material. Depending on what you're trying to do, depending on the phase, the development phase where you might be at, there are times where you cannot get rid of the supports. And you can also use breakaway supports, which is something that we can touch on. There's a whole, I think, MakerBot chats on just the types of supports that you could use. But yeah, it goes to 5 hours, right? So 2 more hours because it needs to create supports. And specifically in Method, you have that option of printing with 2 different types of 2 different types of materials, right? So you have the green material, which is your actual material. In this case, it's slicing for ABS, but I printed it in polycarbonate, super strong, super stiff, really cool. Try it out. And the second material is SR30. So SR30 is our soluble supports. We actually get it from Stratasys, super strong material, super useful. It dissolves in water and some little tablets called EcoWorks, great to use. But if you're just getting started, if it's a very simple part, you more often than not really don't need supports. And then, the happy medium becomes, let's go here, breakaway supports. Did I choose it correctly? Breakaway supports. So what breakaway means, and this is a question that we get a lot for Method, right? Can I print with a single material so that I don't have to waste the time in the second material? And the answer is yes, right? You can make the print with a single material, even using supports. And breakaway supports are basically a type of support that is easy to detach for certain geometries. In this case, I think it will be certainly doable because it creates this very feeble fence, right? This is all you need actually for the part to work. So it goes from 3 hours and 11 minutes to 3 hours and 40 minutes. So you don't get a lot of time increase, but you do get the benefit of having supports. These breakaway supports sometimes can create defects on the part, not on the part itself, but it's going to be harder to remove them entirely as opposed to just using these soluble supports, because, well, soluble supports, drop it in the water and 3 hours later you get the part actually working. So it all depends, right? What are you trying to do? What's the state of the process that you might be at? And what's your goal? I have issues where the supports PVA binds into the wall of the structure that I'm printing. The supports are not needed until further up in the print, but the PVA sticks merges into the surface of the outer layer of the part. How can we adjust the supports? Oh, that's a great question. I love this one. And I'll tell you why in a second. It basically, I like it because it gets under the hood of what we're trying to do here. So I am going to switch over real quick. So the question is, how do I get PVA to not stick to my part? Maybe it's printing too close to the part. Is there a way to control how close the support gets on that part? So I am going to pretend that I'm using, instead of just regular PLA, let's say, you can tell me if you're using PLA or some other material, but for now, I'll play with PLA and PVA, right? The specific question was around PVA. PVA is water soluble, super easy material, I like it a lot, great to use, you just dissolve it in water. And specifically, for that question of when the supports get a little bit too close to the part, there is a setting here. So if you go first print settings, then custom settings, and in here, in supports, you will get, so settings, supports, support generation offset. That is the offset that you will have between the part and the starting of the supports, right? So I can go here and do let's do something crazy like 2 millimeters. This is a little bit too much. I wouldn't recommend that, but this is just to show you what does that mean. And this is, if you imagine, making a sort of an offset of the part, you're removing, you're asking the slicer, the toolpather program to say, okay, start supports at this much offset from the part. And what that does is that it basically prevents as much as possible the supports to touch your part, and it can help a lot with some of the scarring issues. I would also say make sure that you're using, specifically with Method, that you're using the purge tower. The purge tower is going to help a lot in cleaning the extruders when you swap between two types of materials. And here, right, this is a 2 millimeters that I show. You can see how much of, in some cases, right here, it's not going to do the offset because it's basically constrained by the software itself on how far away it can do it, depending on the location that you're talking about, right? But you can see how much space it leaves here. And if I change that again, so just, I'm sorry, but keep this dimension in mind. So it's about the same as a wall thickness right here. So if I change that back to the, where is it? Under angle outset. Okay, so the standard, which is 0.5 millimeters, done. Slice again, and you will see how much closer it gets. So I think that that's a great way to toggle with the offset between the supports and the part. It's a great way to also help some of those parts that might be getting a little bit tricky to decouple from the supports. And also for sure, like using the here, right? Using, yep, there we go. So way closer. It depends a lot of the geometry. This is actually, let's see, is it changing it a lot? Maybe, I'm not sure. Let's move it up. Yeah. So it's here we go, right? So on the top part, on the final, contact element between the part and the support, changes a lot. I would say like playing with that and making sure that you have the purge tower on as well. I'll do a few more questions here, and then we'll start wrapping up. Determine whether, okay, we've done that. Support's always necessary. Advantages of product. Yeah, I think we covered most of the questions. I mean, if you have more questions, do let me know. As always, it's always I don't know how to do this because I'm not a salesperson, but I do think that right now it's a great time to get the method because of the price point that we're getting. It starts at $3,500. I bought my first Rep Plus at $25, I think, about 7-8 years ago. So 35 for this machine, it's just nuts. I would go check it out. It's a really good promo. It's a really good time to be getting a method, especially if, as many companies, many of my designer friends are trying to figure out how do they work from home, what are the, and here's the answer, right? We did the webinar on it, like basically, can you set it up from your house? 100%. Can you set it up in a studio? 100%. So I would consider it. It's a really, 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 I cannot stress this enough. And this is not because I am getting paid or anything, which I am. Of course, I work for MakerBot, but it's a really great time to get the printer. I would consider it if you're in the market for it. And with that, I'll close it up. Thank you guys so much for joining today. Next week, next week we have a new product. I cannot say what it is, but it's a completely new product. I do have a part printed with a new product. It's an exciting material. I'll talk about it, maybe, I don't know if I should be doing this, but just so you know, it's black, it's strong, it's lightweight, pretty lightweight. I use it on my bike. Sorry. Anyways, next week is going to be an exciting one. We'll have a new product coming up from MakerBot for professionals, and it's part of the Method lineup. Do make sure to tune in because it's going to be amazing. I have so many parts to show that I've been printing here in the new setup. I think that you will like it. But anyways, if you have any questions, let us know. Give us a follow if this is something that you like. MakerBot.com/chats for you guys to join our newsletter, so you know in advance what are we going to be presenting the next weeks. Hello@MakerBot or Felipe@MakerBot.com. So that's FELIPE@MakerBot.com. And our social handles @MakerBot both for Twitter and Instagram. And I'll see you guys next time. So thanks again. Join us next time. It's going to be good, I swear. And have a good rest of the day. Bye.